Hi guys, welcome back for lesson 18.2, finding the roots of polynomial functions, day 2. You will need your Springboard book and we will be on pages 284 and 285. You'll want a pen or a pencil and your calculator. And as I mentioned yesterday, we are now going to know and apply the remainder theorem and factor theorem. And technically these two theorems actually do the same thing, so it'll be your choice on which method you prefer or which theorem you prefer. So, remainder theorem says that if a polynomial p of x is divided by x minus k, where k is a constant, then the remainder r is p of k. Okay, so that's going to use, we're going to be using some division for remainder theorem. And then factor theorem is a polynomial p of x has a factor x minus k if and only if p of k equals 0. Okay, so let me just walk you through these two examples and then we will do one together. So example C says to use synthetic division to find the zeros and factors. So basically we're going to use what we did yesterday from examples A and B. So our information from when we found the possible rational roots and we used Descartes' rule of signs, okay? Then it says you also know that the polynomial has either 2 or 0 positive real roots and 1 negative real root. So that's from Descartes' rule of signs. Now it's time to check each of the possible rational roots to determine if they are zeros of the function. So that's what's kind of nice here is that we have positive or negative 1, positive or negative 2, positive or negative 3, and positive or negative 6. So 8 possible roots, and you're going to start using synthetic division to test them. Now I usually like to go in order like they did here. So they started by testing negative 1, and they got a remainder of 8. So they know that that point is negative 1 comma 8, okay? So that's not a root, that's not a 0. But then they tested positive 1, and they got a remainder of 0. So then they know that that point is at 1, 0. So that is a 0 or a solution or a root. So then all they had to do from there, they know that 1 is one of their solutions or roots, and then they just took this and factored it. So remember when we did division, we would write that as 1x squared minus 1x minus 6. So they just factored that, and so they got negative 2 and 3 when they factored that to be the other zeros. So this could be a tedious task, especially if you do not find your 0 within the first 2 tries, but you're eventually going to find 3 out of the 8 possible rational roots that are the real roots, okay, or real zeros. All right, and like I said, we're going to try that in a bit. But before we do that, I want to show you the factor theorem as well. So it's a very similar process, but basically what they're doing is they're testing it a little bit differently. They're taking these and they're plugging them in, and you can use your calculator, what have you, but you have to get out 0 when you calculate this. So basically what they started with is, again, they started with negative 1, and they plugged it in for all of the x values. So negative 1 cubed minus 2 times negative 1 squared minus 5 times negative 1 plus 6. And again, they got 8. So again, they know negative 1 comma 8 is one of the points, but that is not a 0. So then they test their next point, and they plugged in positive 1. Okay, so 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6, and they did get 0. So they knew that was good because 1, 0 was going to be one of the points. Now, unfortunately, unlike the remainder theorem, you cannot just factor and find the other 2 quickly. So you would need to test each of the possible rational roots. So you would need to go ahead and plug in the 8 different numbers. So as you can see, next they went ahead and they plugged in the 2. Then you could plug in negative 2 and so on and so forth. But keep in mind that you know from steps A and B that there should be either 2 or 0 positive real roots and only 1 negative. So once you've found your negative, you can stop testing for that, and then you would just test the positive numbers. So that's kind of a little bit of a shortcut. Okay, but they end up getting the same thing here, that 1, -2, and 3 are the real zeros or real roots. Okay, so now we're going to go ahead and try this. So we are going to do the same problem we did in the last video, but we are going to do it with both remainder theorem and factor theorem. Okay, so remember from the last video that we did the try these A, so we found all the possible rational roots. So I put that here. Then we also did the try these B, where we found the number of positive and negative roots, and I put that there. Okay, so now we're using that information, and we're going to use the remainder theorem to find the real zeros. Okay, so I'm going to start out. And remember, some of my possible rational roots were -1, +1, and -1. So I'm going to go ahead and start out with +1. And I'm going to divide here. And remember your synthetic division, you use the coefficients. So we have 2, 7, 2, and -3. So drop down the 2. 1 times 2 is 2. 7 plus 2 is 9. 1 times 9 is 9. 2 plus 9 is 11. 1 times 11 is 11. And then -3 plus 11 is 8. So again, no bueno here. We do not get a remainder of 0. So we know that that negative, or that 1 is not a solution. So then we try -1. And do the same thing. Drop it down. 2, -2, 5, -5, -3, 3, 0. So we get a remainder of 0. So now we know -1 is the solution. Okay, so that's good. We put a little star maybe. But then from here, let's make this 2x squared, because remember you drop it down 1 degree from the original, 5x minus 3. So now we would be factoring 2x squared plus 5x minus 3. Okay, and you could totally just go ahead and do synthetic division 6 more times if you wanted to, but instead I think this moves a little bit quicker. So remember 2 times -3 is -6, then bring down the 5. What two numbers multiply to give you -6 that add to give you 5? 6 and -1. So then remember, we do have a lead coefficient here, so we do have to plug those back in. So 2x squared plus 6x minus 1x minus 3 equals 0. And then, here I would do my grouping method. I'm going to need a little more room. So I group, and I end up taking out a 2x, and I'm left with x plus 3. And I take out a -1, and I'm left with x plus 3. And then 2x minus 1 equals 0. And x plus 3 equals 0. Okay, and then when I go to solve, I would add the 1 over and divide by 2 and get x equals 1/2. And I would subtract the 3 over, so I would get x equals -3. So if I bring down my original answer up here, which was -1, then I know that my 3 real zeros, are x equals -1, which we got from the remainder theorem using synthetic division, and then x equals -3, and x equals +1/2. Okay, so keep in mind that all of those were part of our possible rational roots, -3, -1, and +1/2. So that helped us. And if we look back here, 2 of them are negative and 1 is positive. So all of those things kind of work together to give us our 3 real roots. Okay. All right, then quickly I'm going to go ahead and show you guys how that works with factor theorem as well. So basically, factor theorem, you're just going to plug in those zeros the same way. So you're going to do 2 times 1 cubed. And again, I'm using my possible rational root. So I'm just starting with positive 1, and I'm going to work my way down. Okay, and like I said, I would recommend just plugging this into your calculator, and then in your calculator, you can keep just switching out the numbers that are in the parentheses. So then you could do -1, and then you could do 1/2, you could do -1/2. You've got to go through and do them all until you have your 3 solutions. Okay, so when you plug in 1, you should get 8 out. When you plug in -1, you should get 0 out. So right away, I would like star that one, and you know -1 is one of your solutions. And then you could keep going. So you plug in 1/2. Oops, that should have had a squared there. So this one is a little bit tedious as well, but again, if you do it in your calculator, it can go quite quickly. Okay, and then you could do -1/2. And obviously, I just keep plugging into the same equation or same polynomial. Okay, when we do these, we would get 0 here and a -5/2 here. So again, whenever you get a 0 out, you know that that is a solution. So we've got -1 and 1/2, and then next we would maybe test, so we did those, now we would test 3 and -3. So I go back here and test these out. Whoa. And I'm just going possible rational root by possible rational root and plugging them in and testing them. Can be done quickly in your calculator. Especially if you weren't a huge fan of synthetic division, this is just another way to do it. All right, so let's see what these equal. So +3 should give you 120, so that's not going to work. But then -3 gives you 0. So then you're good. You know this was a 3rd degree polynomial. So once you have your 3, we don't even need to test positive or negative 3/2. We don't need to because we have our 3 solutions. And those are at -1, 1/2, and -3. And again, those are the same ones we got doing it this way, -1, -3, and 1/2. And they were part of the possible rational roots, and 2 of them are negative, 1 is positive. So we are all good to go. Okay. All right, so I know that's a little bit long and tedious, so we'll do some more practice with that tomorrow in class. Let me know if you have any questions. Have a good one. Bye-bye.